All right, so now we're talking about fish again in Rainy River and Lake of the Woods. And it's apparently at the US-Canada border. I'm not familiar with that place really. But there was a study that was conducted there, and it's near Minnesota, obviously. And they wanted to know how many fish were in that river and the lake. So what they did is capture-recapture. And what they captured, they decided that the population was 160,000. So that means the big N is 160,000. It's a lot of fish. And they caught 1,700 sturgeon. So that was the N sub 1. The first capture was 1,700 fish. They tagged them and released them. And then of the tagged sturgeon, 7 were recaptured. So the N sub 2 is the part that we don't know, and the K was 7. So let's try that out. So we'll do K, so 7, maybe I'll just write it first, K over N sub 2 equals N sub 1 over big N. And so let's plug in what we know. So the K is 7. So 7 over, we don't know the N sub 2. So I'm just going to call it X because even though I don't mind the N sub 2, it's just 2 more things to write instead of 1 more thing to write. So I'm going to just switch it to X. And then that's equal to 1,700 over big N, which is 160,000. So what I'm going to do is just divide those two. 1,700 divided by 160,000, and I get a decimal value which I'm going to leave there, which is 0.010625 equals 7 over X. I want to clear that fraction, so I'll go ahead and multiply both sides by X. Clears it on the right, and so I have 7 equals 0.10625X. So I'm going to divide both sides by that, 0.10625. I think I said it wrong a second ago. 0.010625. And since it's sitting there on my calculator, remember you can use that 1 over X button to sort of flip it over. So I'll do the 1 over X, or the X to the negative 1, and then times 7. And so I get for my X, which was really my N sub 2, I get 658.82. So I'm going to have to go with 659 sturgeon were recaptured. Remember what we were trying to find. It was not how many were tagged or what the whole population is, but how many were recaptured. All right, so when we do this capture-recapture, we assume that what we're doing to the animal to mark it is not making it easier prey. And we are also assuming that the animals that we catch are representative of the animals in the population, that they're not like the ones that were genetically more friendly to be easier to be caught. So that sort of thing. So there's issues there that, and you heard the guy in the video mention it quite a few times, that the dot that he was putting on the snails was non-toxic, so it wasn't going to kill the snails, and it was not going to make them more likely to be prey to a passing bird or whatever else eats snails. So we have to think about that, and if we do something that when we tag the individual, like the tag makes them more likely prey, or it makes it so they can't fly very well, or if it were toxic and it killed them, then we wouldn't capture any of the tagged ones back because they'd all be dead. So if that's the case, the capture-recapture method is likely, if in this case we're saying if the ones that we tag makes them more likely prey, so they're being killed before we can recapture them, then what's going to happen? Are we going to underestimate or overestimate in our recapture? So we can think about a scenario. So let's think about this. So sample where we have n sub 1, let's just say, is 500 turtles. And then our n sub 2, let's say it's also 500. We're going to make this really easy for ourselves. And then let's say that our k, the number that are marked in our recapture, let's say that it's 100 turtles. And so let's figure out what that population would be based on that. And this is assuming that everything goes as it should. So we would have 100 over 500 equals 500 over big N. And we can reduce that if we want, like I did on that last problem. We can do that. So we could say the 100 divided by 500, I think it's 0.2. Yeah, so 0.2 equals 500 divided by n. So then we'll want to multiply both sides by n to clear it from the right. And then we have 0.2 times n. So I'm just going to rewrite over here. 0.2 n equals 500. So divide both sides by 0.2. Then my n, my big N, the population size, is 500 divided by 0.2. And so it comes to 2,500. Okay, so that's going to be our actual population. So now let's do the tags. Make animals prey. So they make them too obvious, and so several of our animals die. So what's going to happen is our N1 is still 500. Our N sub 2, still we could have it as 500. Our K, though, instead of collecting 100, a bunch of our animals were more easily preyed upon, so we're going to collect a smaller number. So we're going to collect, maybe say we collect, I don't know, 25. So it was a really bad tag. Okay, so then when we do our calculations, we're going to have 25 over 500 equals 500 over n. So we have 25 divided by 500. It's 0.05 equals 500 divided by n. Multiply both sides by n. And so we have 0.05 n equals, those n's cancel, so equals 500. Divide both sides by 0.05. And those cancel there, so we just have n equals 500 divided by 0.05. And so that says it's 10,000. So if our tagged people, animals, are more likely to be killed by their predators, then we are more likely to overestimate. Do you see how that happens? If nothing's happening to our tagged animals, then we think we should have 2,500 animals. But if our tagged animals are being preyed upon, there aren't as many of them for us to collect, then we would be overestimating. So we are likely to overestimate. Okay, so now go back and look at this because I want to make sure you understand how I came up with all these numbers. For this initial sample, I just made up numbers that I would have for my capture and my recapture, and then I said, oh, say suppose that 100 of the recaptured animals were tagged. And then I found, using the formula, I found what the population size is. That gave me my baseline. And then I used that as my example where the tagging went bad, and so I have my n sub 1, n sub 2 I could leave the same as whatever I decided to use for my first sample, and then my k I had to make smaller. So I chose to make that smaller because of what was being said up here in the problem. Sometimes the problem is telling you, what if you get more tagged animals than you should because the ones who were captured are just friendlier animals. So you sometimes have that case too. So in that case, I would just bump my K up higher than it was when there was nothing wrong with the capture recapture. So it would maybe be 125 instead of 25. And then I recalculated and saw what would the population be if there was a problem where my tags were causing my animals to be preyed upon more often.